Okay. Good morning, everyone. I'm really excited to be here speaking to you today about the topic which I like, and hopefully you'll also enjoy. And welcome to those who are online, and hope you are able to see the slides and also hear my voice. If there is anything, please put it in the chat. Again, thank you so much for Larry, Sharon, and Nancy for inviting me to be here to speak to you about phenology and yield and how they are impacted by some of the climatic factors, because considering the time, we have very short time. So I'll just focus on one of the most important environmental factor which impacts the yield and phenology, which is temperature. So this will be my outline for the next 45 or 50 minutes. I'll watch the time and make sure that I finish in that time so that we'll have some time for questioning. So I would like to always start with the current status of food and nutrition and climate around the world, because it's very important and how we at Kansas State University and other universities in Kansas are addressing these global challenges and helping people around the world. And then I'll introduce you to the climate change and what is the current status of some of the greenhouse gases. Are you able to hear me okay? My voice is okay? A little bit louder. Maybe like this. Yeah, that's better. Okay. So I'll talk about the current status of the greenhouse gases, and then what are the future trends as well. And then we'll talk about how does this short episodes of temperatures, whether it is a couple of days or a few hours, how would it impact the yield and productivity of some of the crops, grain crops, and also some of the garden crops as well. And then we'll look at what is the impact of the longer term, season-long temperatures, how would it impact phenology and yield. And then always when we talk about climate change, there is also carbon dioxide in the picture in addition to the temperature. So we'll see how those two interact with each other and how do we manage these stresses, particularly temperature. And then if there is time, I would like to give you a global tour of how we are addressing some of these challenges around the world in 14 different countries. I'll only highlight which are relevant to the gardens or the crops which we usually grow in the garden. So if there is time, I would like to just have a few slides on that. So let's talk about the current status of food and nutritional security and also climate. This is a map of the world map which shows you the food insecurity around it. At this point of time, last year, 828 million people around the world did not have access to food, which is unacceptable. And 75% of those are women, and 80% of those regions fall under the places where climate is very warm. And that is not counting the impact of COVID-19 and the current crisis and war which is going on. So if you add those, there will be 1 billion people who do not have access to food, which is not acceptable. Not only that, we're also dealing with malnutrition. I'm calling it as a triple threat. This is the children under the age of 5 who are impacted by various factors. Stunting, they are too short for their age, about 148 million children. And then wasting, which are too thin for their age, about 45 million children. And then also we have issues with obesity as well, but 37 million children are impacted by obesity. That means they are too heavy for their age. So we have a triple threat. We have undernutrition, stunting, wasting, and also obesity that needs to be addressed. Now coming to the climate change, these are the graphs which shows you the current status or the history of how various greenhouse gases have been increasing. The 4 major greenhouse gases are the carbon dioxide, nitrous oxide, methane, and sulfur hexafluoride. All of them have been significantly increasing over the last century. And at this point of time, the current carbon dioxide concentrations are about 420 ppm, which is the highest so far. Just to give you a relevance, in 1960, it was only about 208. So we've gone significantly higher in terms of our carbon dioxide emissions. Because these greenhouse gases trap heat, therefore, it's leading to increasing in the temperatures. So this is the visual which shows you the temperature change over the last 50 years. Pretty much on your left, you see around the world, everything is in yellows or red. That means the temperatures over there have significantly increased. And that number is about 1 to 2 degrees Celsius. And on your right is the global average temperatures from 1850 to 2023, last year. So at this point of time, or last year, we were about 1.4 degrees Celsius warmer than what we were in the beginning of the previous century. And those of you who are following the COP28, COP29 meetings, our goal is to keep it under, by end of this century, keep the temperatures below 1.5 degrees Celsius. And considering what's going on right now, it is going to be very tough. But at least if we can keep it below 2 degrees Celsius, all of us can survive, including plants and other animals and other species. So now, what is the trend in the US? That was a global map. What is the trend in the US in terms of heat waves? Because every time summer comes, we say that it's the hottest summer ever. And when the winter comes, we say it's the coldest winter ever. So it's when you take an average, it doesn't really help us. So we really are looking at what are the extreme temperature heat waves which have been happening in US. There are 4 visuals on there. One is the frequency of the heat waves, duration of the heat waves, and the heat wave season, and then also the intensity of the heat waves. And this gives you the data from 1960s decadal until 2020s. So pretty much the frequency has increased, the duration has increased, the heat wave season has increased, and also the intensity has increased. And if you do business as usual, it's likely to continue in that direction. And when we talk about temperatures, we all know there is a day temperature, and also there is a night temperatures. So what is happening around the world is it's the nighttime temperature which are going faster than the daytime temperatures, or they're increasing more rapidly than the daytime temperatures. And this visual shows you from 1910 to 2020. So our summer nights are going to be much more warmer. And that has a significant influence on the phenology of the plants, irrespective of what type of plants is it. I saw some wildflowers and the wild plants. All of those are also going to be impacted by that, because the warmer temperature, more the respiration, more the carbon is lost. So that will have a negative impact on that, and especially on the phenology. So that was the current status. What's the future? Unfortunately, it doesn't look good. Pretty much everywhere in the world we will see more intense heat waves and the average temperatures going up. On the precipitation side, we'll probably get a little bit more precipitation or the rainfall, whether it's the snow or the rains. But because of the high temperatures, the more evaporation, more transpiration, so that's going to balance off, and we'll see more negative impacts of the heat. So although rainfall is going to be higher, but evaporation losses are also going to be higher, so it compensates for that. So in future, we'll see more extreme events, and also the mean temperature shifting. So if you look at the mean temperature will shift, and also more hotter or extreme hot weathers are going to be much more. So now you may ask, how does it impact the phenology, yield of the grains and the garden crops? So first, let's talk about short episodes, let's say 1 or 2 days or 5 days in the season. If the temperatures are hotter, what it can do to phenology and the yield. When I came to Kansas in 2005, we really didn't have that many. It's almost 18 years now. So we did not have that extreme events happening. We know that July and August will we get hot, but now it's moving, shifting, and also the intensity is going high. So people didn't believe when I said that a couple of days of temperatures can actually have a negative impacts on your sorghum yields or the wheat yields. So I did a lot of work on that, understanding why it is impacting the yields of major grain crops. So just for us, all of you probably have seen milo or sorghum or corn or soybean. So typically plant passes through different developmental stages. When you plant the seed, it emerges, seedling emergence, and then they grow through vegetative stages, and then it starts flowering, and then you have the seed set, and then the seed swell. That is true for any of the grain crops, and also any of the fruit or vegetable crops which has seed or fruit as an economic yield. So, but not all of these stages are equally sensitive to temperatures. Some stages are much more sensitive to temperature, and some are not. So if we know what is our climate or weather in our county or in our place, we can try and adjust our planting dates so that the sensitive stages do not fall in the time when there is going to be extreme weathers. So if that one option you have, adjusting the planting dates, and also selecting a variety which has different durations so that you can avoid that sensitive stage to be exposed to heat stress or drought stress. But obviously, because the weather continues to change, it's a game we have to play to make sure that it's an annual decision we have to make. So the first thing I did was to look at some of the grain crops. I'm showing you for the diversity here, I'm showing you one is sorghum or milo, and another one is peanut or groundnut, and I'll also talk a little bit about common bean as well. So what I did was at Kansas State University in the Department of Agronomy, we have very nice growth chambers where we can control the temperature, we can control the light, we can control the humidity, so that we can actually do this type of research to expose the plants to a particular temperature for a certain duration, and then see what impact it has on yield and yield components. So here, just on your left, so this is the time when the temperatures were exposed. So 0 is flowering, -5, 10, or 15 days before flowering, 10, 15, 20 days after flowering. This is a floret fertility, meaning that those flowers, were they fertile? And if they were fertile, were they forming the seed? Because at the end of the day, yield is seed, especially for the grain. If you ask farmers or anybody who is in the business of agriculture, what do you want? Number 1 is yield, number 2 is yield, and number 3 is also yield. All right, so and you only get yield when you have grain or seed. So what it does, if you have controls are those. So if you have, these were my temperatures, optimum temperature and high temperature, and I expose them to just 5 days of heat stress. So if you have heat stress for 5 days, your yield is going to decrease by about from 100 to almost 50. And then so that's at the time of anthesis. If you have the stress at anthesis, you get that much loss. And this is 5 days before anthesis, and this is 5 days after anthesis. So that's the most sensitive time, 5 days before anthesis and 5 days after anthesis. So then 5 days is still a lot, right? So then we thought, okay, how about 1 day of heat stress? Can it have an impact on yield? So this is, I mean, I have sorghum data, but I should just thought for diversity, I'll show you a different crop, peanut. So here you have, again, same thing. When you have at anthesis, you have the maximum reduction, and about 3 days before anthesis, you have the maximum reduction. So those are the two most sensitive stages, at the time of flowering, and then just a couple of days before flowering. And you may ask, what is happening those times? So before flowering, three or 4 days before flowering, the gametogenesis are happening. There's 2 things, right? Gametes, which one of them is the pollen, another one is an ovule. So those pollen and ovules are developing at that point of time. So any stress that happens, they'll be not fertile. They'll be non-viable, or they'll be sterile. And if you have a sterile pollen or you have a sterile ovule, you'll not have fertilization. So that's what it is. That's the main reason this is happening. So, and this is on wheat, because Kansas, we have to talk about wheat. And this is, again, you see about 0 days at the time of flowering, and few days before flowering is when you lose the maximum spike-like fertility. So that's what is happening with the short duration, even 1 day, 5 days of heat stress. And those 5 days doesn't have to be successive. Any of those flowerets which are exposed to that particular, because there will be multiple flowerets at different stages, right? So for example, wheat flowers for a week or 2 weeks. So any of those flowerets which are at that stage, those will be the one which will be sterile. So tomatoes are the same. So this is a tomato. You see developing buds. Now I'm focusing only on the reproductive stages of the development. So you have this buds, flower buds. You have immature flowers, you have mature flowers, and then they fertilize, and the fruit starts to develop, and you have a mature fruit. So that's a development stage for the tomatoes or peppers. And what is happening between that few days before anthesis is the microsporogenesis. That's what I meant, the pollen development and ovule development is happening. So if you have stress, even when the buds are this small, that's the most important stage. When those buds are exposed to, even for a day of heat stress, those buds will be fertile. So you may have seen infertile or sterile. So those you might have seen when your garden has a lot of flowers, but you have very few tomatoes. And then later on, maybe season, because you'll get new flowers and they're not exposed to stress, then they'll form the fruits. So that's the major reason is the loss of sterility of the florets. So here is an example where it shows that not only the per flower, not only the number of pollen grains is decreased with heat stress, the number who is germinating, once it falls on the stigma, it has to germinate. So even those germinating are significantly decreased, and the viability is also decreased. So those are the things which are happening. At the time of flowering, even though the pollen is fertile, it's not able to germinate. That's why you see the loss of fertility. And then if those 3 days before flowering, those are not even, the pollen is not even fertile. So those are the two things which are happening. And I won't go through this. And now this is the same. I want to give you another example of peppers, both in terms of chili peppers and also bell peppers. So those are slightly two different types of plants. So again, this is a typical development stage: seedling, vegetative stage, flowering, seed set, formation of fruit, and the fruit development. Even for that, if you have controls, you have fruit weight of this much and seed set. When you expose them to heat stress, the fruit weight drops and also the seed set drops significantly. Almost, you see, there's only temperatures, these are the temperatures. 5 days before anthesis, you have that. And at the time of anthesis, again, it drops from normal 36% to 12%. And then if you have the entire season, then you have a significant reduction. So that's exactly what's happening, irrespective of the crop, whether it's wheat, sorghum, rice, tomatoes, peppers, or anything which has to form a fruit or a seed. Those two are the most important stages. Let's get this. So what are the mechanisms, right? I told you pollen is lost. Ovule is also last time. Being at Kansas State University, so I was digging more into the science behind it. So there's basically, you don't have to pay attention to those, but I'll just summarize in a very succinct way. So basically there are 5 things which are happening. Why do we lose sterility of fertility of pollen or ovule? We all know all organs or cells are made up of membranes. All cells have membranes, right? So what happens under high temperature stress is, generally there's a thing called reactive oxygen species. All membranes, when the stress happens, the reactive oxygen species goes up and they bind with the membranes and damage the membranes. Under normal condition, there's a balance. There's things called antioxidants, you might have heard. So there's the reactive oxygen species and there's antioxidants. Plant or humans, anything keeps the balance between that. When there is stress, what happens is that reactive oxygen species goes up, antioxidants come down, and that damages the membranes. It's a membrane of the pollen, membrane of the ovule, membrane of mitochondria, membrane of chlorophyll, anything is. So that's why you lose the fertility. That's number 1. Number 2 is that all membranes also have lipids or fats in it, fat or lipids. So what happens is oxylipids, the type of lipids, oxylipids go up. And these, though again, they'll have the damage. And the third mechanism is, for a cell to survive, we need carbohydrates or sugars, as we all do. So what happens is that when there is, pollen is a very tiny thing, right? Very small. And you think plant has such a big thing, so many leaves, it produces a lot of sugars and a lot of carbohydrates, which is true. What happens is that all of these carbohydrates or sugars move from the leaves to the anthers, to the anther wall, but it cannot go beyond the anther wall because the membranes have to have transporters which take the sugars from outside and put it into the pollen grains. So those transporters are not functioning. Therefore, you may have a lot of sugar in the plant, but it doesn't reach the pollen, and therefore does not have any energy. So that's a mechanism for that. So those are some of the key mechanisms through which pollen are ovule. So that was short duration, 6 hours, a day, or 5 days. So now the other part of climate change is that we see the season-long temperatures are also increasing. Maybe not as much as a couple of degrees, but even half a degree or a few degrees centigrade when throughout the season that's happened. So this is a summary of my 12 years of work at Kansas State and before. So I developed these temperature response curves for all the major grain crops, saying that when does actually yield starts decreasing and how fast it decreases, and do different crops have different optimum temperatures where they function very well, or ceiling temperature where they do not have any formation of the seed. So this is harvest index, which is a ratio of the grain versus the biomass. So when the harvest index is 0, that means there is no grain. So therefore, you have this temperature response curves. So for all the crops, wheat is the most sensitive, where the ceiling temperature is 31. When there is 31 degrees Celsius, there is no yield. Rice is 35. Sorghum or milo is 38. Millet or pearl millet is 41. So there is a variation between the crop. So you have to choose the right crop. In future, if this continues to happen, increase in temperature, we might have to switch our crops. There are multiple crops, but unfortunately, the diversity of crops which we are currently working is being lost very rapidly. So you'll have to make a choice to which type of crops can be grown. As a consumer, we'll also have to make a proper decision on what type of grains we want to eat. But there is diversity. Nature has given us a lot of things, but we just have to make sure that we choose the right plant. There's a lot of diversity we need to utilize. And then from the legume side, dry bean is the most sensitive, 32. Peanut is 39 and soybean is 40. So we have options. And this is again for tomato. So this is development, fruit development with increasing temperatures. The fruit development is meaning time for development is decreasing. So just like anything else, the phenology, which is the developmental stages, we talked about germination, vegetative stage, flowering, fruiting, and maturity. These are all stages. And most important factor which drives how quickly they go from one stage to another stage is driven by temperature. So when there is temperature increase, they accumulate degree days, and this faster they accumulate the degree days, faster they reach the next stage. So the whole purpose of plant is what? Survival. When it senses that temperature is high, so it said, I need to survive. I need to finish my life cycle faster. I need to make sure I have at least one seed so that I can survive the next generation. So that's what it is. Accumulation of degree days, higher temperature, faster it accumulates with an idea that I will form a seed. But then if that heat happens, then the seed is not formed. So that's why with any plants, increasing temperature will fasten the phenology. I'll skip this one. So hopefully now I'm able to convince you that with the evidence-based experimental data that whether it's grain crop, garden crop, fruit crop, they're all extremely sensitive to short episodes of temperature stress and also season-long temperature stress. And the most sensitive stage being flowering, where the germination of the pollen is impacted. And the second one is few days before flowering, when the viability of the pollen and the ovule is impacted. If those two are impacted, you do not have the seed set, or there's no fertilization, there is no seed set, therefore there is no seed or grain. Okay. So now I told you that the second component of climate change is carbon dioxide. So you may have heard that increasing carbon dioxide increases the plant growth, which is true, because photosynthesis, that's how the plant converts the light energy and the carbon dioxide to grow. So when there is more carbon dioxide, there will be more growth, because right now the limiting factor of the enzyme, which is ribisco, which is limited by the carbon dioxide. So increasing carbon dioxide will increase the growth, whether it's leaf, stem, root, or biomass. Okay, but it doesn't help with the seed set. So that if you are in the business of not the grain crops or not the fruit crops, you're okay. You'll have more biomass with increasing temperature, increasing carbon dioxide. But if you want the seed set or the fruits, then that will have a negative. So I did that. I'm going to show you 3 crops here: common bean and then sorghum. So this is the total biomass, and there's 2 things here. Blues are the normal carbon dioxide, 350 at that point of time. And the red is the increased carbon dioxide. And then this is your temperature. So across all temperatures, temperature is decreasing biomass, seed numbers, seed yield, and the seed size. But carbon dioxide is increasing it because, as I said, the photosynthesis right now is limited by carbon dioxide. So more carbon dioxide, better it is, so they'll increase. Okay, so but there is no impact on seed. There's no benefit of elevated carbon dioxide on seed set. So any crop which you have, food crop, which needs grain, it will not be benefited by elevated carbon dioxide at cooler temperatures. Cooler temperature, you'll see benefits. But as soon as you go optimum and above optimum, all the positive effects of carbon dioxide will be negated by the negative effects of temperature. So the interactions are good when you're in a cooler region, but when you reach to like Kansas, any further increase will have a negative effect for grain or food crops. If you are in a business of spinach or leafy vegetables or something else, or forage crops, it'll be fine. You have a lot more biomass. Okay. So how do we manage this? That's the most important. Which is tough, right? So we have multiple options. We just have to be open and be willing to change, because change is hard to do. But once you cross the tipping point, we will not have any choice but to change. So there are options, fortunately. So agronomic options, early planting. If you can plant early and avoid that heat stress or drought stress during those sensitive stages, you should be, that's an escape mechanism. And then you can adjust your plant population. And then you can, if you have irrigation, try and irrigate so that at least the microclimate will be a little cooler than the outside climate. And then keep the plant healthy. If the healthy plant can withstand the stress better than the weak plant, whether it's pests or diseases or weeds, make sure that those are healthy. Those are just agronomic management. But we also have a lot of chemicals which are being tested, because all those things which I was talking about, the membranes, plants communicates. We just don't, it doesn't talk, but it communicates from one organ to another. Roots are talking to the leaves are talking to the flowers are talking to the roots. So it's a plant communicates, and that communication happens through hormones. So if you are able to communicate to the plant, saying that if the leaves say that, hey, it's getting hotter, so then maybe the pollen will do something, it will flower late or early to adjust. So there's a lot of plant, we think that plants are not talking, may not be talking to us. If you have eyes, we should be able to see them. They're actually talking. They're saying, they're not talking, but they're expressing themselves in a different way, right? So that's why you can manage the hormones, you have growth regulators. And as I said, if you're able to increase the antioxidants so that the reactive oxygen species are eaten away by them, then you protect your membrane. So we have some of those. And nowadays, there are also some of the microbials which can actually send the signals to various organs to avoid the stress as well. And then you have different types of varieties. And then we also have different types of tolerant genotypes. We have screened multiple genotypes. Not all genotypes are equally sensitive. Some of them are tolerant. So maybe we need to use those tolerant genotypes in our gardens, in our crops. And if there is not, we have to develop new tolerant lines. And as I said, there's a lot of genetic diversity. So we have to make sure that we go to nature, look at the genetic diversity and pick up. Just for example, sorghum or milo. There's 45,000 varieties. 45,000. And then if you talk about wheat, there's 120,000. If you talk about rice, there's 200,000. And how many of them actually we are using in our breeding program? Less than 1%. So there's a lot of Mother Nature has given us a lot, but unfortunately we have just picked one and stick to that for our entire life. So there is options. We have to screen those lines, identify which are more tolerant, mostly wild species, and then use them in our breeding program, because those species, wild species, may not be high yielding. They're tolerant to stress, but they're not high yielding. So we have to use those, breed with our other varieties, and make sure that you get the yield out of it. So there's a lot of opportunities. So that was the story about the temperature, how it impacts phenology, how it impacts yield components and yield, right? So hopefully that's okay. Now I'm at 30-minute mark, so I can actually take you to the world tour. So again, I would like to summarize this key message and then move on to the next one. Okay. So even short periods of high temperatures, few hours, a day, or 5 days, not happening in sequence anytime, can negatively impact the fruit set or the grain set, which is the main yield. And how does it impact? It makes the pollen and the ovule sterile if the stress is happening before flowering. If it is happening at the time of flowering, even though the pollen and the ovule are fertile, it just doesn't germinate. So those are the two messages which I would like to give you. And I didn't talk about the quality. I just talked about the yield, but the quality traits are also impacted by high temperature stress. And then we have genetic variability, we have diversity. So we can actually address this by screening and identifying the right genotypes, which is tolerant, and use our breeding programs to transfer those genes into our current varieties so that we can withstand the upcoming stress. So that's the message. And phenology, again, more the temperature, faster plants tries to rapidly develop. So phenology, time from sowing to emergence, flowering, maturity will shorten if there is high temperatures. That's just plants' way of survival. So that message is clear. So now, okay, so now let me now talk about the sustainable ag, because I want to set this premise. I need to be here because people are watching. It's tough to stand at one place and speak, but I know not all people can be here, so I'll be here. So I talked to you about 828 million people not having enough food. And then malnutrition. I showed you the numbers of just children under the age of 5. But if you count all of them, about 2 billion people are malnourished. 2 billion people are malnourished. Some is undernourishment, some are overnourished, obesity, and also lack of nutrients in it. And then micronutrient deficiencies are also very iron deficiency, anemia, especially in weaning pregnant women and weaning mothers. Iron deficiency, anemia is very big. And the second big one will be zinc deficiency. And the third one will be the vitamin A deficiency. So that's happening around the world. So we at Kansas State University are trying to address that. How can we help smallholder farmers around the world to address those key challenges? And that's where my innovation lab is called Sustainable Intensification Innovation Lab, or SIL. This is funded by USAID. It's funded by all of you, actually, because your tax dollars are the ones which the US government gets it, and then they give us funding for the universities to help around the people around the world. It was in 2014 is when we started. It was $50 million grant, and then later on they added more. So it's $75 million were given to Kansas State University to help people in Kansas, beyond Kansas, in US, and going beyond US around the world, because now we're all global citizens. We're all global citizens, because anything which happens in a small town in China or in Ukraine or in Middle East has significant impact on all of us, directly or indirectly. So we're all global citizens. The whole concept of sustainable intensification is to provide access to safe, nutritious, and healthy food at all times to all people from existing farmland without damaging our natural resources. Because in the past, what we've done is whenever we were short of food, we brought more land into agriculture. But we don't have that option anymore without cutting the forests or the native grasslands. So when you do that, you'll have a negative impact on the environment. So the whole concept is produce more from less, or not going and cutting more forests and bringing more land, which is hard. So, but we have to do that. And there are multiple ways. I'm not going to go into that, but that's the whole concept. So what are we doing? We are working in 14 different countries around the world. So in Asia, or Southeast Asia, Cambodia. This is the world map, Cambodia, Bangladesh, and now coming to Eastern Africa, Ethiopia, Rwanda, Tanzania, Malawi, Niger, Mali, Senegal, Burkina, Ghana, Haiti, Honduras, and Guatemala. So we have research, education, and outreach programs in these 14 different countries, helping smallholder farmers to produce more from their existing land and nutritious food, more importantly. I won't go through, so it's a big program. That's what I would say. So we bring in, it's a big program. So we have about 130 scientists, and we work with 120 organizations. And that includes 20 US universities, and we have trained masters and PhDs, almost 250. Capacity building the human. You cannot put an economic value on a person's success in life or educating a person. So that's our portfolio. These are the partners which we have. So what are we working on those things? Conservation agriculture principles. And we can use this in the home gardens. And I'm 35-minute mark, so I'm okay on the time. Right on 45 minutes, I'll finish. So conservation agriculture. So what does conservation agriculture means? There are three principles to it. Number one is not tilling your land. You're not disturbing the soil. Number two is continuous soil cover. There's always something on the soil so that it doesn't evaporation and losing and everything. Third is there is diversity. There's crop rotations. You're not producing the same crop or the same plant species every time in the same land. You rotate or you mix. So those are the three principles. Minimum tillage or no tillage. Continuous soil cover. It can be from residues. It can be from live plants. And then diversity and the rotations. Thank you. Right. So these are some of the work which is done in Ghana. And everything is with smallholder farmers. When I say smallholder farmers, they are less than 2 hectares or 2 hectares of land. So largest farmer in any of these countries would probably not even have more than 10 or 20 hectares, which will be about 50 acres. The largest farmers probably have, which is, the scale is different. In US or in those, scale is different, but issues are the same. Everybody wants yield, everybody wants profits, everybody wants nutritious food. And everybody wants market for their produce. So those are common, whether it's a smallholder farmer in Bangladesh or Haiti, or it is a big farmer in US or UK. The principles are the same. You want more yield, you want more benefit or economics, and you want a good market, and you want a good nutritious food. So those are the same issues. So it's just a difference of scale. So here, soybean, we saw that minimum tillage can actually give you 10% yield benefit, not too much, 10%, but still good. Sometimes it's not going to give you benefits in the yield because you have to have, when you have a minimum tillage, you need herbicide options. And you also need an equipment to plant under the residues. So those smallholder farmers don't have that option. They can't buy herbicides and they don't have heavy equipment to be able to plant seed in the residues. So therefore, they may not have yield benefits, but they have economic benefit because they don't have to spend labor. So your labor, household labor, or if you're hiring a labor, you have savings from the labor. So they may not be yield benefits, but when you do the economics, the labor savings would probably be beneficial to them. And then these are tide ridges, meaning that you have, basically, you have to plant, if you can bridge them across the slope, that way, whenever there is rain, you're capturing that rain. And sometimes if you tie them, you can see that they're tied. So meaning that when the rain is falling, it'll have more time for infiltration. So you can capture, because right now the intensity of the rainfalls is higher. The duration between the two rain events is farther. So whenever there it rains, it does not flow away. You tie the ridges. You have the ridges, and you also tie them. So for more time, capture rain, more time for infiltration. And then using those conservation agriculture principles, these are smallholder farmers in Ethiopia. So we have done work with them where they use whatever available mulch, anything, leaves, their rice straw, milo straw, any material which they can cover. So it's commercial home vegetable gardens. So they have this mulch put on the ground. We use grass clippings. Yeah, our lawn, when you mow the lawn, we can use the clippings and you can have a continuous cover. And then there are drip irrigations. So this has increased the yields of the smallholder farmers by 20%. And it increased the women's income by 40 to 50%. And the reason this is good is because when they grow wheat or rice or sorghum, they are far away from the house. So women don't have access to that. But anything they grow in and around the house, they manage it, they see it, they can sell it, they can get the money out. So that's why we focused on home vegetable gardens rather than the fields which are far away from the house. So especially to make sure that women have access to this. So that was that. And then electricity is an issue. So we say that, okay, women spend about, some of them actually walk 2 to 3 miles to get water from a source. And then if there's a well, they have to use the pulley. So it's a lot of labor on that. So we use solar power, but not only water lifting from the wells, but also water delivery. So that helped, especially the women farmers very well. So, and then these are the solar power. So you can lift, store it on the tanks, and then the gravity. And if it is far away, then we lift, we pump it, and then store it on the tank, and then gravity irrigation. So that's that. And then sometimes we also need to know when to stop irrigating, right? How much to irrigate. So just because you have you have the water and you can lift it and you can deliver it, over irrigation is also an issue. As much as under irrigation is, over irrigation, nutrients will be lost, and there will be erosion, and then those fertilizer, if you're applying, those will pollute your water streams. These are all of issues. So you need to make sure that you're not over irrigating. So we have these small things which will, as soon as the soil moisture reaches that level, it just pops up. It tells, okay, stop. So there's nothing scientific about it. Well, technique is scientific, but you don't need to worry about it. So as soon as the soil reaches 70% of the soil water holding capacity or 80, you can set that up and it pops. Then you stop irrigating. That's the easy way to do that. So we are using those things there. And that's one example in Ethiopia. We're doing the same thing in Cambodia. And there we are working on indigenous vegetables. Again, I was talking about the loss of diversity, right? There's a lot of indigenous vegetables which are very nutritious and healthy and climate resilient. So we are working on those. These are ridge gourds, bottle gourds. So there's a lot of there's so many different types of vegetables and fruits which are very healthy. So we are working with those. And then when you have a garden, the borders are there. You have a borders. How about growing something on the borders? And that too, perennials. That would give you something throughout the year. So we have this Acacia pinnata, which can be grown on the borders of these commercial home vegetable gardens, and their leaves have extremely high vitamin A. So they can eat the leaves. And you may have heard about moringa, another species, moringa. And they say that moringa can cure everything but the bald head. There is an annual moringa conference which happens every 5 years. I was not even aware of it. So moringa last 20 years, moringa has become such an important crop that all the people around the world come together biannually or to talk about what moringa has to offer. So it's huge. And then wild gardens for these also help, wild gardens for the bees, for pollination and everything else. So that's in Cambodia. And I'll skip this, Tanzania. And then another one is, how do you manage insects and diseases? These chemicals are always there, but you can also use plants to repel. So that's what we call it as a push and pull technology. So this is your regular maize. Okay, so this is your regular maize. So what we can do is you can plant a row of desmodium, which is a legume or a dicot. It produces volatiles. Leaves produces volatiles and repels the pests. And then on the borders, you have napier grass, which attracts the pest. So it keeps your main crop protected. So that's what we call it, push and pull technology. And this is just one technology for maize using desmodium and Napier grass. And then you probably have seen this marigold, beautiful yellow flowers. It does the same thing. So this is a marigold, which is I think it is tomato or peppers. Then if you have this marigold, it actually attracts the pests towards themselves and protects the main plant. So there are the simple things which we can do and reduce the use of pesticides and increase the diversity and the pollination components. And this is just the example of in Guatemala. I was there last month, and they're broad bed and furrow. So they have the bed, they produce tomatoes, and then the furrow irrigation. And sometimes they actually have this to control the weeds as well. And then pest management is done by pheromones. So they have pheromone traps which they put it on. So there's multiple ways you can address that. That's just Guatemala. This is I'm at 45-minute mark, so I'm going to stop. This is my home garden in Kansas. Oh. This is my wife. And we have about very small area. And because I probably didn't introduce myself. I come from India and came to US in year 2000 and came to Kansas in 2005. And then we are used to our indigenous vegetables, but luckily we have the weather in Kansas where we can produce. So these are bottle gourds, and these are ridge gourds, and this is a different type of leaves. And then we like spice. So these are really hot chili peppers. Hot chili peppers. And then I'm surprised that they can grow as tall as this is my daughter there. So we are using some of those. This is a bottle gourd because it's a gourd. It's a gourd, but it's a bottle. It's a longer. It's called bottle. Yeah, and then this is ridge. They are ridges. And then there's also another one which is there's multiple types. So luckily we have the season in Kansas to grow all those. So we don't have to go to Chicago, drive to Chicago to get our vegetables. We actually produce ourselves. With that, I would like to conclude saying that climatic conditions, particularly high temperature, will have negative impact on phenology, yield and yield components of major grain and garden crops, especially those which form the fruits. And then even short episodes of high temperature, if occur at critical stages, will have negative impacts. And those critical stages are a few days before anthesis and at the time of anthesis. And then that will decrease the seed set, seed numbers, and seed size. And there's no beneficial effects of elevated carbon dioxide at higher temperatures. Only at cooler and optimal temperature you will see, and only on those crops which do not care about the seed or the grain. Spinach and everything else, it's okay. And then climate smart and sustainable agriculture will help improve adaptation and mitigation and resilience of our food systems. But to do this, we need a lot of people, a team, not from biophysical scientists, but also social sciences, understanding the behavior, how farmers or producers adopt a technology or disadopt a technology, and everything. All people have to come together to address the global challenges we have. Again, don't forget, 828 million people not having access to food, 2 billion people suffering from malnutrition, and then we have issues with climate change. So let's work together and address these global challenges. Again, thank you very much for that. And these are the people who do the hard work. I have the privilege of saying things here, but these are the people who manage our labs. Again, we have 10 minutes for 48-minute mark. So, yes, ma'am.
From K-State, I assume that you go out and talk to Kansas farmers and producers. How receptive are they to some of these new changes?
I should admit, when I first started in 2005, they were not that receptive. But when time changes, they're experiencing themselves that extreme events are happening. I mean, climate change is a very sensitive issue. Again, the reason being, because probably we are using the wrong terminology. I'm just being very honest here. Because, when we talk about climate change, we always think that it is going to be one way. But especially, as I said, Summer, hottest temperatures. Winter, coldest temperatures. Average, no change. Simple math, right? High, average, no change. So that's what people are saying. Well, when you look at the average temperature, it's not bad. But what we are seeing is extreme weather events. Look at this year. The pollen, I mean, I'm allergic to the pollen. So this year, the pollen came very early, right? And then the heat is the wheat crop. Sometimes we have, we plant wheat in October, September, October, and then harvest in July, right? So usually it germinates, and then we go through that process of dormancy. And then the spring comes in, and if the spring comes in, the wheat will start emerging, and we can have like any cold snap, 1 day of cold snap. If the growing point of the wheat is, because we are getting some high temperatures few days in January or February, so the wheat thinks, okay, I'm ready to go, comes up, and then we have 1 day of 30 below 32 Fahrenheit, and it's gone. The entire crop is gone. So we are having this. People are convinced that there is extreme events happening. So we need to take care of that. That. And then that's number one. Number two is that the misconception that elevated carbon dioxide is going to solve the issue, because we have more carbon dioxide releasing, which is good for the plants, more photosynthesis, but it's good for only forages, good for spinach and the leafy vegetables, but not good for wheat or sorghum or peppers or tomatoes or anything which produces grain or foods. So that's that piece. And the third misconception is that if you irrigate, it's okay. You can get over the negative effects of heat stress, but not. Because I've done enough work that the irrigation can help a little bit. It can cool, because if you have irrigation, whether it is coming from rain or if you have the groundwater, the way plant is doing is it's cooling itself, right? So to escape, it's cooling itself. So you need water. But unfortunately, in Western Kansas, we don't have water. Or in wheat, we don't irrigate our wheat as much as we would love to because we don't have water. So there is some help if you have irrigation, but if you don't, you're out. That's number. And the last one is that you can withstand stress only to a certain extent. You cannot run away from it. If temperatures keeps going or the drought comes, plant also can withstand a little bit, but at the end you have to give it up if that is continuing to grow. So yes, so people are experiencing, and there's a little bit more receptive to extreme weather events. Yes.
We've got the heat of the air, but then we have sun intensity. If shade cloth were put over tomatoes, would that benefit in any way the production of blossoms? And
yes, it will help a little bit, because when we put shade, we're also minimizing the sunlight, which is required for photosynthesis. So there is a balance. You can maybe, because being in Kansas, we have clear skies and we have a lot of light intensity. So cutting down by 20% of the light using the shade will be helpful. But if you do more, then it's not, because it's not going to get light energy is the one which drives the photosynthesis. So that's where all the sugar and the carbon and the nutrients comes through. So there is a balance. You can probably use the shade for a partial time when there is heat coming from the sunlight, and then everyone. Yeah. But again, let's not doing too much is not going to be helpful. So if you shade it all season, then you don't get enough.
So you had said climate change is not a good word.
Yes, because climate variability, extreme events.
What should we be calling?
I would say extreme events, climate variability, because change is just mean, right? So,
yes.
So if you say, are you experiencing more extreme events? I believe 99% of the farmers in Kansas would say yes. But if you say, do you believe in climate change? Probably not. So it's the same thing, but it's just the way we brand it, right? So that's why extreme events are happening. We're experiencing it, so that's something to that. Yes.
do you get the sense that Pioneer and Monsanto and all the other seed manufacturers are beginning to try to develop hybrids that are going to be more appropriate for the future, or are they still focused on yield?
They are now realizing more, and they're actually putting more into drought tolerance and heat tolerance as primary areas. And again, especially those private companies, those you mentioned, they are screening and they are putting a lot of efforts on climate resilient or heat tolerant and drought tolerant variety. I would like to say a few things here. I came to Kansas in 2005. Came to Kansas City, drove from Kansas City, passing through this to Manhattan. I did not see a single field of corn. Honestly, I didn't see, or maybe, yeah, I did not see. Maybe a couple of them, but not. If I take the same drive, everything was Milo or so. I take the same drive now, I won't see a single field of corn, Milo. It's all corn. So those are all drought tolerant corn from private companies, and same. So they are working on it. So yes.
Okay. Have you done any research on the temperature impact, not what's done on the yield, but on the nutritional quality of the food?
Absolutely. Yeah. We've done quite a bit on grain crops. So the protein will increase, but everything else will decrease. Especially the micronutrients, the antioxidants, the vitamins, they are negative. Protein, because it's a yield and it's a trade-off between the nitrogen and the carbon. So protein, you may see a little bit of increase in the protein content or the concentration, but the oil content, the carbohydrate content, the micronutrients, the vitamins, and everything else is going to be negative. That's for wheat but if you look at the fruits and vegetables, you will probably same thing. The vitamins, the antioxidants will be low. Yes, and we'll come back to you. Sorry, but yeah, first year and then.
So with respect to varietals that produce flower type grains, spelt, rye, wheat, which flowers earliest? You're not studying them. You have no idea.
I have no idea.
So with respect to the different grain species, millet, sorghum, I don't know. Your chart.
Yeah. The major five major cereals. So again, there's a huge diversity, as I said, 45,000 accessions of sorghum, 120,000 for wheat, 200,000 for that. So there's a lot of diversity. But when we grow them right now, everything is driven by the temperature. So, and then within a crop, we have early maturing types, we have mid maturing, we have late maturing. So irrespective of which of these you use, when there is temperature increase, early maturing will become early, mid will become early, late will become early. So there's a lot of genetic variability. But phenology will be rapid irrespective of the species, irrespective of the varieties. They'll all be fascinating. That's just a simple mathematical growing degree days accumulation.
I was looking to splice a gene from millet, if millet bloomed earlier.
Yeah. So yeah, that's.
I would want to put that.
Absolutely. So let me yeah, that's, I mean, you said that very nicely. So when we get the sunrise, okay, the temperature goes up, noon, solar noon, it comes down. That's how it is, right? So as I said, even few hours of high temperature stress, those flowers will be sterile. So if you have a plant which have early morning flowering, if it flowers in the morning or it actually flowers in the night, it will escape all that stress. So that entire trait is called early morning flowering trait. And I worked on it 2004 or 5 and identified rice varieties, labarimas, wild types, which actually flower early in the morning, 7 o'clock and 8 o'clock, and they pollen fertilize, an embryo is put. It just waits for the optimum temperature to come and then the embryo. So that's called early morning flowering trait. Millets is one of those which actually flowers in the night. Cowpeas, probably must have heard the black-eyed beans, they flower in the night. So wheat, rice, they flower in the noon. So we are looking at that early morning trait within those varieties to use that and then use emerging. So that's just within the day. So if it is avoiding the pollination in the noon and having the pollination in the morning, it's fine. Once embryo is formed, it's very tolerant of heat stress. So that's a great thing. And then the second one is early maturity is helpful because, for example, it's probably worth telling a story here. Sorghum or milo. Now we have in summer we have not summer but yes soybean, corn, and sorghum. Okay. Corn and soybean go very early, April, and then we plant milo a little later. And when is our hottest period? At least we used to guess it used to be last week of July or first week of August. So sorghum and pearl millet, sorghum, if you plant in April, it does not germinate because it's not a tropical, it is a tropical crop and it cannot germinate when the temperatures are cooler like soybeans or maize. So to avoid that heat stress during flowering, we are working on cooler temperature stress for emergence so that we can plant sorghum with corn and soybean so that instead of flowering in July and August, it actually flowers in June, late June, so that it is, or early July, so it escapes that heat stress. So we are improving the heat tolerance by breeding for cold tolerance in germination, emergence time. So yes, early flowering, avoid that, complete the life cycle before, that's good. Yes, sir. Sorry.
I was just going to ask about the consequence in Western
Unfortunately, it is declining rapidly, much faster than what we want, much faster than how much we can replenish. So we'll have no choice but to shift the crops because, I mean, in terms of water requirement, if I have to say, let's say we produce three crops, right? For example, we'll have to move from maize to milo, and then to sorghum, and then to maybe other millets or teff or other millets. Yes, so we'll have to move from those other species. Luckily we have the diversity, but consumers have to make a choice. So yeah. So unfortunately, as I said, the Vara aquifer is rapidly declining, and then we are over irrigating our crops because those regions. It's a sensitive topic, but I'm just going to say it. But just it's because we should grow the crops which are suitable for that region. Is corn suitable for Western Kansas? In some places, yes, but not all of Western Kansas should be producing corn because it needs a lot of water. But there is market for it, so I'm not blaming the producers. Absolutely not. But as a consumer, we need to figure it out. So Mother Nature has given so much diversity of the crops and the plant species. We need to produce appropriate crop and appropriate plant in an appropriate environment. Then we'll all be happy.
Oh.
Yeah, yes.
Been trying to develop perennial,
Yes, Kernza.
the flowering and perennial wheat react to them. Yeah.
Excellent question again. So perennials have a role to play, but when it comes to phenology, it's the same thing. Doesn't matter it's an annual or a perennial, because perennial was, even if it is perennial, it still finishes its life. It emerges, germinates, vegetative growth, flowers, seeds, then we cut it, comes back up again. It's not coming back from the seed, it's coming back from the tillers. So that process is still the same with the perennials around. The phenology is going to be increasing, the pollination, everything will remain the same. But the good thing about perennials is that you probably don't have to till it again, and then some root growth and microbials, soil microbiodiversity, and that will allow the health of the soil, and then you can produce it throughout the year as well. So yes, perennials have a role to play, and that's one of the things which we are working on. Those of you, I think there's a perennial rice available now. course, it has Land Institute. Most of you know in Kansas, Land Institute is an excellent organization. Nature Conservancy is another one. So, but Land Institute has entire focus of them has been on perennials. Konza is their product, which is a perennial, but they're working on the others. But but for example, sorghum or milo, by genetics, it's a perennial. We made them annual. We bred it out for 100 years to make it an annual. Pearl millet is the same way. Maize is, corn is not, but I think we have made, so now last year, the discovery of it, maybe 20, I don't know if it is 2023 or 2022, but AAAS, the American Association for Advancement of Sciences, identifies one innovation which is most game-changing or most important thing. So that was perennial rice. That is, of course, developed in China. Put a lot of money and effort because Chinese produce a lot of rice and they eat also a lot of rice. And same with South Asia and Southeast Asian people. So they have now developed perennial rice, 8 cuts with no yield losses. So I think that would be good if it works across other places as well. So perennial work is on perennial rice is happening. Work on perennial sorghum and milo is happening, breeding back to the roots in a way. So, but perennials are extremely important. Perennial grains, but of course, there's perennial trees and agroforestry, and those are all there. But in terms of grains, perennials have a role. It will be good for our climate, good for our soils. Yes.
Much of this is agricultural, which is the priority
Mhm.
for food production. Are there, what programs are in process looking at native plants and, how that, the whole thing with the biosystems and
Mhm.
all of those things that affect the natural world?
That's right.
I mean, not that this is natural, but what we see in our natural environment and all of the spring and the migrations and how they all overlap with each other. What work's being done there on natives?
There's a lot of work being done for native plants, especially from agriculture, agri-food systems perspective. Look at the rice, wheat, maize, sorghum, pearl millet from the cereal side. So most of those natives of those, each of those 5 which I've told, native plants are the wild species from where they originated or they developed or taken. So we are screening these for stress tolerance. So because that's where we'll find the genes for drought tolerance, heat tolerance, disease tolerance, and pest tolerance. So we are doing a lot of work on screening the native on the wild species of these food grain crops which we eat. That's one way we are addressing the food systems. Of course, native grasses and others, that's there. But thinking from a food perspective, grains, so there's a lot of work going on in the native and wild species to identify the genes which have the tolerance for drought, heat, and other abiotic and biotic stresses, because they are more tolerant, but then they're not productive. So we have to screen them, identify, and then use the breeding process to make sure those genes are incorporated into our a lot of work, and that's where you're going to find the tolerance. We're not going to find the tolerance in our cultivated species. Thank you.